Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is make two arrays equal by reversing the subarrays. So we are given two arrays. One is target and then the other is array. And then we need to make sure that these particular arrays are equal. That we can do via reversing this particular subarray, which is present in the target or array. Suppose let's say uh, we are given 1, 2, 3, 4. Now we need to reverse some of the subarrays which is present in the target so that it will be equal to this particular array. Suppose if I take this particular example 1, 2, 3, 4, I want to at the place of 0th index. So I'm going to reverse this particular subarray which is going to be 1, 2. It will be reversed to 2, 1. Now I got the 2 at the 0th index, so that is fine. And then after that, at one index we need to get the 4. That means I'm going to reverse this particular 1 3 4. Then I am going to get 2 2 4 and then 1 3 1. Now we are going to reverse those and then we are going to get this particular 2 4 1 3. So suppose let's take, we have a particular array which is like 2 comma 3 comma 4, and then let's say we have another array which contains like 1 comma 2 comma 3. Can we make, can we reverse this particular subarrays and then make it equal to array? No, we cannot. Why? Because we have 4 here but we do not have 4 here. So we cannot make transitions and then make it to equal to array. So now what we are going to do is, like, we are going to check the frequency of this particular array which is present in target and then array are equal or not. If it is equal, then we can say that all the numbers present in the target are present in this particular array. So if these frequencies matches, then there can be a possibility that the target can be equal to array. Suppose let us think that we have those number of elements which is present 2, 3, 4, and then let's take another array which contains like 3 comma 4 comma 2. Now let us think that I need to get I need to get 3 at this particular index which is 0, which is 0. Now what we are going to do is we are going to take that particular 3 and then we are going to swap. That means we are going to swap this particular 3 with the 2, and then suppose if we got 3 and then 2 here, now we are going to take the left index. Suppose let's say we want to move this particular 3 to left again, then we are going to swap this particular 3 with the left element and then we are going to keep on doing till 3 gets to that particular point which is present to the left index, and then we want 4 at this particular index. Now what we are going to do is we are going to swap this 4 with the left element which is present, and then we are going to keep on doing until 4 gets to at this particular position which is index of 1, which is present in this particular array, and then we are going to do it for 2 again. So this process will give us the actual array which we want at this particular case. So that's how we are going to get the particular array which is array from the target. Now what we are going to do is we are going to check if the frequency present in the target is equal to frequency present in the array. If this matches, then we are going to get that particular target or array, and then we are going to return the answer. So we are going to keep it simple. We are going to take the unordered map and then we are going to add target plus plus and then we are going to decrease this array of I minus minus. Suppose let's say we have frequency target. So the frequency of 2 in this particular target is 3, and then the frequency of 2 at this particular array is 3. Then we cannot have a match. So that's why we are going to return it as false. Whenever uh, the frequency not equal to 0, then we are going to return as false. Suppose the 2 present in this particular array is 3, and then 2 present at this particular array is 3, then we are going to say that it is match, and then we are going to return the true. Now let us discuss about the time and space complexity. The time complexity is going to be big of n. Why? Because we are traversing the array only once. And then if we come to the space complexity, we are going to take whatever the range of this particular numbers which are the length of this particular array is going to be our space complexity. So the time complexity is going to be big of n, and then the space complexity is going to be big of n. Yeah, that's all for this video. Thanks for watching the video.